In this next example, we're going to write out all four quantum numbers for the valence electrons in a chromium atom. And remember that chromium is one of the anomalous electron configurations, and its electron configuration is going to be argon 4s1 3d5. So if we would write the block diagram out for this, it would be 4s with one upspin electron and 3d with 5 upspin electrons. So here is our block diagram for the chromium, and we're going to label each electron number 1, number 2, number 3, number 4, number 5, and number 6. So if we list each of these 6 electrons, we need the N, the L, the M sub L, and the M sub S quantum numbers for each one of these. The first electron is in a 4s orbital, so it's going to have N equal 4 and L equals 0. In an s orbital, M sub L is limited to 0, and our spin quantum number is going to be plus 1/2. For the second electron, we're in a 3d orbital. So the principal quantum number is going to be 3, whereas our magnetic quantum number is going to be 2. The M sub L value, remember when we have a d orbital, and I'll kind of draw these underneath here, an M sub L value for the s orbital is going to be 0. For a d, it could be plus 2, plus 1, 0, minus 1, and minus 2. So these are the M sub L values that are going to correspond to each of these electrons. So M sub L will be plus 2, and M sub S is going to be plus 1/2. Okay, so for electrons 3, 4, 5, and 6, they're all going to be in a 3d orbital. So N is going to be 3, L is going to be 2 for each of these electrons. All of them are going to have a plus 1/2 spin. And the differentiation between each of these electrons is going to be where in that d orbital these electrons are. So we're going to have plus 2 for the first electron, plus 1 for the second, 0 for the third, minus 1 for the fourth, and minus 2 for that fifth electron in each of those d orbitals. Okay? So just to kind of give a summary of these quantum numbers, the principal quantum number tells us the energy level in which the electron is located. That gives us very, very general information. The magnetic quantum number tells us the orbital in which the electron is located. The M sub L value is going to tell us where in the orbital the electron is located. And the M sub S value is going to tell us the spin of the electron that we're trying to identify. So we need all four of these numbers to properly identify and distinguish each electron in an atom, and this is the process that we would use to do that.